Hello, everyone. Welcome to Shield Insights. This particular series is called Talking with Shehnaaz and Ram, and this is actually episode number 2. In episode number 1, we covered the first two tactics of the MITRE ATT&CK framework, and we specifically covered reconnaissance and resource development. In this particular episode, episode number 2, we'll be covering the actual attack matrix, the first two tactics of the actual attack matrix. So we will be covering initial access, which Shehnaaz will take us over. And after that, we'll be covering execution. So without any further delay, it's over to Shehnaaz. Shehnaaz, how does an attacker get that initial foothold into a network? What does initial access really involve?
Right. So as Ram mentioned before, we spoke about reconnaissance and resource development, which were the preparatory tactics of the MITRE ATT&CK matrix. So those are the tactics that an attacker would use to prepare himself to launch an attack in any network. So initial access, according to me, is one of those early stages of an attack that an organization can detect out and out using the right set of tools and security solutions. So initial access in simple terms is nothing but an adversary intruding your network by exploiting any of the vulnerabilities. Now, once they intrude your network, they're going to establish a foothold in your network. So once they do this, it becomes easier for them to gain access to your network off and on, and they can do this for prolonged periods of time. So initial access has about 9 techniques that the attackers use. So using any of these techniques, they establish that initial foothold in any network. So one of the most important and prevalent methods of gaining initial access to any network is by compromising user accounts. So it's a no-brainer, right? So when someone wants to intrude a network, they go about compromising user account, stealing credentials. That's where social engineering or phishing all come into the picture. So that's the reconnaissance and resource development part of it that they use here to compromise any account in a network. So there are basically 4 types of accounts that an attacker would look at when they talk about compromising user accounts. The first one is default accounts. Now, these are the kind of user accounts that are built into the operating system, like the admin accounts or the guest accounts. So in most cases, the admin accounts have username as admin and password also as admin. So these are the kind of default accounts that they look at exploiting when they have that initial access point into any of your networks. And the second type of accounts are the domain accounts. Now, these are a little critical because domain accounts can give anyone access to users, computers, and also to services. So once an attacker gets into your domain user account, they're going to be accessing your resources easily. So they do this with the help of OS credential dumping or using passwords or reusing passwords to be more specific. And then there are your local accounts. Now, local accounts are extremely easy to compromise because phishing attacks are becoming more sophisticated. Social engineering scams are all over the internet, so they can gain access to your local computers very easily. But it's not going to stop with that. They're going to elevate their privileges or create credential dumps from using your local accounts and elevate their privileges and laterally move across your network. And the fourth type of accounts that adversaries can compromise are the cloud accounts. Now, these are also similar to your domain accounts in a certain way because your cloud accounts give you access to a lot of resources in one go, and they call it ease of access, but there's a lot of vulnerabilities involved in having extended access, especially when your data is on the cloud. So you have to constantly monitor all of these accounts. So the best way to begin mitigating these kind of attacks is to sort of modify the passwords of the default accounts or accounts that come with preset passwords. So we need to look at all of these accounts and modify their passwords. And sometimes even hardware devices come with these sort of preset usernames and passwords. We need to look into all of those accounts and modify those passwords. Now, that's one technique. The second technique, and this is also really prevalent, which is the external remote services. Since we started working from home, the concept of having a network perimeter sort of became very blurry. We didn't know where to draw the line because a lot of us started working from home. So we started using these external remote services to access resources from within our network, and attackers saw an opportunity there. So if there's a VPN connection to my network and if I'm using it, all they had to do is eavesdrop or launch a man-in-the-middle attack to see the kind of resources that I have access to at the other end of the tunnel. So one thing to do here is to look for vulnerabilities in your remote services and patch them. So one classic example would be the Bluekeep vulnerability. So the Blue Cape vulnerability was out there for a long time, and even after a patch was released for it, there was a lot of ignorance about, patching up the solutions for the Blue Cape vulnerability. Even till date, a survey revealed that there are about 1 million laptops and computers that are not patched for the Blue Cape vulnerability itself. So these are certain things that we need to be extremely cautious about when we are when we are giving remote access to people to our resources within the network. And some other techniques involve hardware additions to your network. Let's say you have a critical resource, and there's the hardware called your keystroke injector. So that hardware is capable of having in memory the kind of keystrokes that you give into that critical system. So these are the hardwares that you need to look out for in your network, which could pave attackers the initial foothold in your network, which could give them the way to establish those footholds in your network. So to do this, you can use the DHCP protocol, look at all the hosts in your network and see which kind of hosts you trust and which kind of hosts you don't. So that's the level of granularity we must incorporate into monitoring for initial access attempts. And one more thing I'd like to talk about is the supply chain compromise. Now, this is almost similar to the zero-day vulnerability because, and also zero-day vulnerabilities are more prevalent in your external remote services. They come with a lot of vulnerabilities and we're not aware and we get attacked. So one such thing is your supply chain compromise, wherein you buy a software and before it becomes part of your network, before you install it in any of the systems in your network, someone modifies a piece of information or a piece of code to execute something malicious in your network. So that happens as well. So you need to be cautious about the kind of software that you're installing, even if it comes from legitimate sources. So check for updates, look at your patch management solution to see if there's any unnecessary piece of code or any untrusted piece of information that's part of the lines of code that is involved in a software that you're installing. Now, these are some of the techniques that the attackers use to gain initial access into any network.
Great. Okay, Shehnaaz, thank you so much for that. You gave a very good overview of initial access. In fact, it was more than just an overview. You went at quite a good depth over there.
Thank you.
I did have a couple of questions as you were talking about it. Now, with initial access, are there certain things that we can do to prevent it? Could you tell us about that?
Yeah, there are a few generic concepts that you can incorporate into your networks to sort of prevent against initial access. The first one is a no-brainer. It's enforcing stronger password policies. So when you do that, you automatically secure a lot of your user accounts by using stronger passwords. And the second one, as I mentioned earlier, is looking for vulnerabilities and patching them before the attackers get to you. And the third one is segmenting your network very wisely, because if an attacker is in your network, we always have to be prepared for the worst. So segmenting your network in such a way that your critical resources are isolated and are more secure will give you the upper hand even if there's an intruder in your network, and will give you time to deal with whatever the attack is. And the other thing would be giving the right amount of privileges to all of your user accounts. So if you adopt the principle of least privilege while provisioning user accounts, that will make a huge difference, because once an attacker compromises a user account, their next step in the next 48 hours would be to compromise a bigger account or to compromise a privileged user account or even the domain controller. So the more we restrict access to each and every user account, the difficult it would be for the attacker to move laterally or to escalate their privileges and carry out what they want to carry out in your network. And the last important thing that you could do is analyze your log data. So there's a log on log information that you'll have, and also application log data. You can look into these log data, or you can analyze the log data to identify who's accessing which resource in your network and who's accessing which user account in your network.
Great. Thank you so much, Shehnaaz, for that. Some very good insights about how you can prevent initial access. But it kind of got me thinking, is there a way you can also detect initial access, especially by insiders, because they seem to be the biggest threat nowadays?
Right, that is a very good take on the initial access itself, because insiders, they're already in our networks, and it becomes easier for them to carry out malicious activities from within the network. But here's where we can make use of some of the fancier kind of technology in IT security itself. So you can make use of machine learning based modules. One such modules is user and entity behavior analytics module. So it detects abnormal user behavior and entity behavior in your network. Since it's machine learning based, the module is capable of understanding each and every user and computer's behavior in any network on a day-to-day basis. And if at all a user deviates from his baseline of activities, or if at all a user deviates from his usual pattern of activities and does something abnormal, we will be notified with the help of the UEBA module. So we can make use of such advanced modules to make sure that we are able to detect behavioral anomalies from insiders, because insiders are a bigger threat, as you said, and they are already inside our networks, so it'll be easier for them to execute malicious actions from within our network. On that note, Ram, can you tell us about the execution tactic of the framework, what it entails, how it works, what are the techniques?
Yeah, definitely, Shehnaaz. So execution happens to be the second tactic of the attack matrix after initial access. And the word execution, well, that gives it away, right? So the adversary is trying to run a malicious code or execute a malicious code. That very simply is what they try to do here. Now, it could have a couple of objectives, major objectives. The first objective could be plain and simple. It could be just to steal data. So adversaries can execute code to exfiltrate data. So that's data exfiltration. They can also execute code to find out more about the organization itself, to find out more about the network of the organization that they want to take down. So it could be a way for them to do reconnaissance or domain enumeration. Now, all of this, right, execution, it can be done either on the local machine or it can even be done from a remote location. So all of that is possible. When it comes to the execution tactic itself, there are 12 different techniques that the MITRE ATT&CK framework identifies for us. And I'm going to just list them out for you. The first technique is command and scripting interpreter. Then you have container administrative command, very similar to the first one. Then you have deploying container, where the adversary is just deploying containers to evade defenses. Then you've got exploitation for client execution. That's the fourth technique. Then you've got inter-process communication, native APIs, scheduled tasks and jobs, shared modules, software deployment tools, system services, user execution, and Windows management instrumentation. So the first technique, like I told you, is command and scripting interpreter. This is where the adversaries use command and script interpreters to basically take down organizations, to run their malicious code. A lot of networks, or a lot of operating systems, I should rather say, come inbuilt with whitelisted applications and tools such as PowerShell. Of course, the command prompt itself could be used. So PowerShell can be leveraged for all the wrong reasons by adversaries. It can be used for all the right reasons by the IT administrators, but in the wrong hands, it becomes a huge problem. So I've seen this in action actually, where PowerShell can be used for domain enumeration. So an adversary, for example, can find out the password policy of the company. They can find out the users, the list of users in a particularly sensitive security group. They can find out the list of administrators in that particular domain. So all of that can be done using PowerShell. Likewise with the command prompt as well. The other thing that I would like to talk about is this other technique when it comes to scheduled tasks and jobs. Again, a very, very useful utility to have. You have something called the at.exe utility, which can be used to schedule tasks to run at a specific time and date. But again, if this gets into the wrong hands, the adversary's hands, it can be leveraged for the wrong reasons, right? So they can actually make sure that a malicious code runs at particularly, at a specified time and date. And there you go. Once that is done, the organization can be compromised, right? Likewise, you can also have Windows management instrumentation. Just in the year 2020, towards the beginning of 2020, we had this new ransomware strain called Snake ransomware. It is also, by the way, called ECANS. So that is just snake spelled backward, ECANS. So this particular ransomware strain leveraged the Windows management instrumentation to execute some malicious code and make the network behave in the way that it wanted, right? So these are some of the ways in which adversaries can execute malicious code.
Thank you so much, Ram. Your insights were great about execution. So when you were talking about PowerShell, so can you tell me if we will be able to detect if an adversary is using PowerShell for all the wrong reasons? Because you were talking about the right and wrong reasons. So will we be able to detect if someone's using them for the wrong reasons?
Yeah, definitely. You can detect the wrong usage of PowerShell in your domain. It can be done. You just have to have the right kind of tools for it. Now, there are tools available that let you know exactly who ran PowerShell at what time.
Right.
These tools actually tell you what kind of script was run and the actual metadata of the script as well. So in case a user is running a malicious script, now brute force attacks can be done using PowerShell. So if a particular commandlet is being run and you have set certain rules in place so that whenever that particular commandlet, that malicious commandlet is being run, you get alerted about it. Right. Then it's very good. You get alerted about it in real time, and you can take action right then and there. Now, like I said, PowerShell can be used for all the wrong reasons. And it's very, very easy for even a non-privileged user to use. So again, back to your point about the insider threat. So if it's an insider who has gone rogue, a non-privileged insider on top of that, they just have to basically run a commandlet which goes as exec bypass. And then they can bypass the inherently built-in features, the built-in security features of PowerShell. So it's extremely, extremely important for an organization to monitor what's happening on their PowerShell.
Right, that makes complete sense. Thank you so much. So is there also a way to detect if an unusual process gets started in your network?
Yeah, again, something that's very, very important for organizations to do. You've got to be able to detect these unusual processes. Back to your point about UEBA. So in case a process runs and it has never run before, or it is not run so frequently that it becomes accepted behavior, you can actually detect that. Right. You can detect where it was run, when it was run, who ran it, and on what host it was run. All of these things can be detected. And then what you can then do is, once you detect it, you can then take the appropriate action to put an end to that, to put a stop to that. Or you can also put into motion certain workflows so that whenever a process gets run, and it's a malicious process, especially let's say that it's a very, very sensitive server, and you don't want malicious processes or any kind of processes to run on that server, you can actually write a workflow. The administrator can write a workflow where they can kill that particular process. Not only that, they can disable that user account as well. Right. So those are some of the things that can be done.
Right. Thank you so much.
Sure.
So I learned a lot of new things today, Ram, about execution in general. So that brings us to the end of this episode of the talk show series. And Ram and I will meet you in the third episode with 2 more interesting tactics from the MITRE ATT&CK matrix. Thank you so much for watching.
Thank you.